The James Webb Space Telescope, humanity's most advanced eye in the cosmos, has revealed something extraordinary. Far across the void, just over 4 light-years away, a faint and mysterious glow flickers on a distant world, Proxima Centauri b. This is the closest known exoplanet to Earth, and what Webb has observed is unlike anything we've ever seen. Could this be the first artificial light from an alien civilization? At first, it sounds like science fiction. But the data are real. Webb's infrared instruments have detected repeated pulses of light coming from Proxima b. These signals are structured, rhythmic, and persistent, too consistent to be random natural phenomena. Unlike auroras, volcanic activity, or thermal emissions, which scatter light unpredictably, these pulses follow patterns, almost as if they were designed. Proxima Centauri b orbits a red dwarf star, the smallest and coolest type of star, yet notoriously volatile. Red dwarfs are prone to violent flares that can strip a planet of its atmosphere over time. Yet Proxima b may have retained its air, creating the possibility of a habitable environment. It sits in the so-called Goldilocks zone, where temperatures could allow liquid water to exist, a fundamental requirement for life as we know it. Scientists have long suspected that if life exists nearby in the galaxy, Proxima b is among the best candidates. What makes this discovery so tantalizing is the nature of the signals. Webb's infrared observations reveal faint but consistent emissions from the planet's permanently dark hemisphere. Unlike Earth, Proxima b is likely tidally locked. One side constantly faces its star, basking in eternal daylight, while the other side remains in perpetual darkness. If life developed there, it would have to adapt to extreme conditions. Perhaps an intelligent civilization could have invented artificial illumination, creating cities or settlements in the night side of their world. The patterns Webb detected are striking. Brightness levels fluctuate in a way reminiscent of city lights viewed from orbit. It's a rhythm that suggests design, structure, and perhaps even purpose. Astronomers like David Kipping from Columbia University urge caution, but they admit the signals demand closer examination. This isn't simply a glitch or instrumental error. There is something real happening on Proxima b. The implications of these observations are profound. The lights could be urban in nature, evidence of an intelligent species managing their environment. Or they could serve another purpose entirely, beacons or communication systems transmitting signals across space. Some scientists speculate that advanced civilizations might use directed energy, modulated light pulses, or lasers to communicate across interstellar distances. Traditionally, SETI, the search for extraterrestrial intelligence, has focused on radio waves. But Webb allows us to extend that search into the infrared spectrum, which penetrates dust and planetary atmospheres more effectively than visible light. Adding to the intrigue, the planet's atmosphere shows unusual chemical ratios. Methane is present at levels inconsistent with what would be expected from natural processes, while carbon monoxide appears scarce. On Earth, methane is largely produced by life or industrial activity. Could this be a biosphere with complex ecosystems, or an industrial civilization managing its atmosphere? We must also consider alternative explanations. Could these lights be caused by geological processes, volcanic activity, thermal vents, or luminescent minerals? While possible, such phenomena rarely produce the consistent, symmetrical patterns observed. Natural lights are typically chaotic. The emissions on Proxima b appear to follow a schedule, almost like a power grid cycling through a planet's night. Detecting such dim light next to a star that outshines its planet by billions of times is an extraordinary challenge. Webb's success relies on a coronagraph, which blocks the star's intense glare to reveal faint planetary light. Future missions promise to improve this capability even further. NASA's Habitable Worlds Observatory will carry even more advanced starlight blocking systems. Meanwhile, ground-based giants like the extremely large telescope in Chile, equipped with adaptive optics, will be able to observe exoplanets in unprecedented detail, potentially confirming the nature of these glows. Imagine, for a moment, that these lights are real and artificial. A civilization orbiting our nearest star, just 4.24 light-years away, might be observing the universe in ways we can barely comprehend. Are they explorers, scientists, or survivors, thriving on a world bathed in radiation and extreme conditions? Could they have developed technologies to manipulate their environment on a scale we can only imagine, massive reflectors to illuminate the night side, orbital solar arrays to power underground cities, or even energy systems far beyond our current understanding? The philosophical implications are staggering. For centuries, humans have looked up at the stars and wondered whether we are alone. This discovery could mark the first time we have a tangible hint that the universe is not empty, that life, and perhaps intelligence, exists beyond Earth. Even the possibility of such a civilization challenges our perspective on what it means to be human. How do we relate to beings living in a world unlike any we know, under a sun that is smaller and dimmer than ours, yet more volatile? Skepticism remains essential. Science requires careful analysis, and follow-up observations are already planned. Different viewing angles, deeper infrared scans, and coordinated efforts between space and ground observatories will be critical in verifying whether these glows are indeed artificial or if another, currently unknown phenomenon is at play. Yet, regardless of the outcome, the discovery itself reshapes our understanding of the cosmos. The universe is no longer a distant, silent void. Even faint lights on a nearby exoplanet can ignite wonder, drive scientific exploration, and inspire imagination. And if these lights are from an intelligent civilization, then humanity has taken its first step into a broader cosmic community. Across the darkness, from a world just over 4 light-years away, another species may be saying, "We are here." The James Webb Space Telescope has opened a door to the unknown. Proxima Centauri b, once a distant point of light, now pulses with possibility. Every flicker, every pattern, challenges us to rethink life, intelligence, and our place in the cosmos. As we continue to watch, to measure, and to imagine, one thing becomes clear. The universe is alive with questions, and perhaps, answers. For the first time, humanity is not just looking at the stars. We are beginning to converse with them.